All right, so today we're going to actually start differentiating. This, I think, is a lot of fun. This is really kind of at the heart of calculus, something you're going to keep doing. So I'm going to go over basic differentiation rules today. And the first one that we're going to start with is the derivative of a constant function. This is literally the easiest one that we're going to do. The derivative of a constant function is 0. That's it. So y prime of -4 is just 0. S prime of t of 45 is 0. F prime of x of 0 is 0. And y prime of k pi over 2 is just 0. That's it. That's the easiest one you're ever going to have. All right, let's move on to single variable. Single variable basically is just going to be 1, right? So f of x is equal to x. F prime of x is equal to 1. S prime of t is equal to 1. X prime of t is equal to 1. So that's just a single variable. The derivative of a single variable is just 1. Pretty simple. Let's take it up a notch. We've got the power rule. So the power rule, I've written out the definition here. If n is a rational number, then the function x to the n is differentiable, and d of dx of x to the n is equal to n times x to the n minus 1. This is the important part. You move that value n in front, and then you subtract 1 from that value. So here we have y equals x squared. The derivative of y equals x squared, y prime, is going to be equal to 2x, right? I didn't write 1. You could. It's correct, but I did not because I don't need to. F prime of x is going to be 4x cubed, right? I moved that 4 in front. I subtracted 1. Y is equal to radical x. I'm going to rewrite that as x to the 1/2. So y prime is going to be equal to 1/2 x to the negative 1/2, which I can rewrite as 1 over 2 radical x. And you really probably shouldn't leave a radical in the denominator, but let's do it for now. G of x is equal to 1 over x. I'm going to rewrite that as x to the negative 1. So g prime of x is equal to negative x to the negative 2, which I can rewrite as negative 1 over x squared. Similarly, f of x is equal to 1 over x squared. That's x to the negative 2. So f prime of x is going to equal negative 2x to the negative 3, which is equal to negative 2 over x cubed. Here, y equals 1 over y to the 2/3. That's going to be equal y to the negative 2/3. Actually, why did I write a y here? This should be an x. This is an x. This is an x. Ignore me. So y prime is equal to negative 2/3 x to the negative 5/3. Looks good. Yep. And then I'm going to have negative 2 over 3x to the 5/3. Hopefully all of that makes sense so far. So we've got the power rule kind of under our belt. Let's move on to a general power rule. This is just the power rule plus coefficient. The derivative of the term a to the xn, where a and n are real numbers, is a times n to the x to a times n times x to the n minus 1. I didn't say that very well, but hopefully that made sense to you. So basically all you're going to do here, like we've got y equals 3x squared. Now we're going to multiply 2 and 3 before we subtract that derivative there. So that exponent, I mean. So y prime is going to be 2 times 3 is 6, x to the first. S prime of t is going to be negative 15, t squared. I'm going to rewrite this as 6x to the 1/2. So y prime is equal to 3 x to the negative 1/2, which is equal to 3 over radical x. Then I've got g of x is 3x squared. I can rewrite that as 3x to the negative 2. Now you might not have to do this, but I like to rewrite them. I just think it makes things so much easier. So that's negative 6x to the negative 3, negative 6 over x cubed. Here we've got 4x to the negative 1/2. So f prime of x is going to be a negative 2x to the negative 3/2, which is negative 2 over x to the 3/2. Then we've got, oh, this is beautiful, beautifully messy. We've got negative 8 x to the negative 4 thirds, right? So y prime is going to equal, negative 8 times negative 4 is a positive 32 thirds, x to the negative 7 thirds, and I can rewrite that as 32 over 3x to the 7 thirds. All right. Hopefully that made sense to you, just kind of advancing on what we did with the basic power rule earlier. So now let's talk about sum and difference rules. Sum and difference rules. The derivative of f of x plus g of x is equal to the derivative of f of x plus the derivative of g of x. And likewise, the derivative of f of x minus g of x, I need to bracket that in, is equal to the derivative of f of x minus the derivative of g of x. So let's find here. We've got f of x equals x cubed minus 5x squared plus 2x minus 7. Basically, what this means is you're just going to find the derivative of each of these terms and keep adding and subtracting as you would. So f prime of x is equal to 3x squared minus 10x plus 2. Plus 2 because the derivative of 2x is 2, and then the derivative of 7 is 0, so I don't need to write that 0 in there. Here, I'm going to have y equals, well, 5 times 2 fifths is going to be 10 fifths, which is just 2x to the 4th, plus 4x cubed plus 6x. Okay. Then I can go on. I'm going to rewrite this as x to the 1/3 plus 5x to the 1/2. So g prime of x is going to be equal to 1/3 x to the negative 2/3. Is that right? Negative 2/3 plus 5/2 x to the negative 1/2. So I can rewrite that as 1 over 3x to the 2/3 plus 5 over 2x to the 1/2, or 2 radical x, whatever you prefer. And here, y prime is equal to, that's 5x to the 3/2, so that's 15/2, x to the, looks like we're going to have negative 1/2, or no, not negative 1/2, just 1/2, right? 3/2 minus 2, yep, I got that. All right, minus 30 thirds is 10, x to the 2/3, minus, and this is actually 4x to the negative 1, so this is going to be minus 4x to the negative 2, right? And I can rewrite all this. I've got 15 over 2 radical x minus 10 x to the 2/3, I can just leave, minus 4 over x squared, and that's all okay. All right, so hopefully that made sense to you as well. Now, let's look at, I think we can kind of skip these two. I can give you the answers though. H prime of x is equal to 6x plus 8 over x cubed plus 1 over radical x. You don't need to see me work through it though, I don't think. And here, f prime of x is equal to 16x plus 4 plus 3 over x squared. If you want, go ahead and take some time, work through those, kind of figure them out, just kind of a fun exercise, but I think you've seen me do enough, you don't need to see me do more. Now, I'm not going to go through a lot of examples of these, but I actually just want to show you our trig functions. So the derivative of sine, these you're just going to have to memorize, unfortunately. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. We're not going to use these next ones quite yet, but I'm going to teach them to you anyways. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent. And the derivative of cosecant is negative cosecant cotangent. I don't have a great way to remember these. You just kind of have to do it. And then finally, something to note. The cosine of x plus h is equal to cosine of x cosine of h minus sine of x sine of h. And sine of x plus h is equal to sine of x cosine, there's an extra c in here, cosine of h plus cosine of x sine of h. These are going to be really useful to you, kind of when you're simplifying trigonomic derivatives and things get more complicated, so remember those as well. Now, the last rules that I want to teach you today, the last basic differentiation rules, are exponential and natural logarithmic functions. I'll do the natural log first because it's actually a little bit harder, but basically if f of x is equal to the natural log of x, then f prime of x is equal to 1 over x, and x has to be greater than 0. That makes sense because we don't want to divide by 0, right? And your natural log function, you know, looks kind of just like shoo, going off into forever. So 1 over x, natural log of x becomes 1 over x. The exponential function, the actual easiest derivative to do, if f of x is equal to e of x, then f prime of x is e of x. That's it. It's the exact same thing. So I've got two examples here. One is just natural log and the other incorporates both. Here we've got the natural log of x cubed. Well, I can rewrite that as f of x equals 3 natural log of x. You hopefully remember your properties of logarithmic functions. So f prime of x is just going to be equal to 3 over x, right? 3 times the derivative of the natural log of x is 1 over x. That's it. And g of x here, we have g of x is the natural log of x squared times e to the x. I can rewrite that as 2 natural log of x plus x times the natural log of e. Again, I just using those properties of natural logs, I can move these exponents out front. So now I'm going to have 2 over the natural log of x, is derivative is just x, plus x times the natural log of e. Well, the natural log of e is just 1, and the derivative of x is just 1. So this is g prime of x. Pretty simple. I mean, I think it looks complicated when you first see it in action, but then once you do it, hopefully it makes a lot of sense to you. So that's it. Those are the basic differentiation rules, and we're going to advance more and start using product rule, quotient rule, chain rule. We're going to kind of up our game a little bit, but these are the basic skills that you'll be using throughout. So if you have questions, as always, put them in the comments, and I will see you in class. Bye!